All right, so this lesson is about solving quadratics using factoring. And you should have already done factoring before, but it's probably been a little while, so I'm going to try to refresh your memory and remind you of some shortcuts just to make sure that you're factoring things correctly. So remember, we've done standard form so far, and I told you that the biggest part about standard form that was helpful is that it helps you find solutions. Well, one of the methods to finding solutions is going to be factoring, and we'll talk about another method tomorrow, but factoring, if it works, is a pretty quick method, which is why we're taught how to do it. And we're going to be using factoring for some other things later on as well. So this is an example of something that has been changed from standard form to factored form. You know that standard form tells you the y-intercept, and it tells you if there's any vertical stretches or compressions. But factored form is going to give us the last part of the parabola that we haven't talked about yet, and that is the solutions. The roots, the zeros, the x-intercepts. It's going to tell us where this parabola is going to be crossing the x-axis. So in factored form, that's what this is that you see to the left. The reason that it gives us that is, remember, we can write or change each of these to find solutions. So the same way that you think about inside is opposite, we're going to do that here as well. So since this says x plus 3, I know that the solution must be at x equals 3. Or we can name that as an ordered pair 3, 0. I personally think that this is the best way to name the solution or the x-intercept or the roots or the zero, however you want to name that. I think I tend to call them roots more than anything. But that's kind of up to you exactly how you want to write that. So then if I name the roots for this other intercept, that's going to be -8, 0. Know that most of the time when we factor, we're going to be getting two different roots. We'll talk about tomorrow what the other options are, but this is what we're looking for, is where these functions are going to cross the x-axis. So let's look at, I think I have 5 examples for you, and I'm really just trying to do one of each to bring everything back to you. So let's go ahead and dive into some of those. So the first thing you're going to want to note is that you always want to divide the GCF out first if possible. And I think you probably remember that. So this first equation we're going to do, we're going to factor y equals 4x squared minus 8x. So the first thing we want to do is see, is there anything that's in common for both of those? And I can divide a 4 by both of those, but also an x. So you want to think about factoring as undistributing, right? When we distribute, we multiply, so we're undoing that. We're like writing a problem to look like a distributive problem, so we're going to be dividing. So I'm going to be dividing the GCF out of both of these, which we said was 4x. If I divide that out, that's going to give me x for the first one and -2 for the second. And I told you we're undistributing, so I'm going to write this as y equals 4x, x minus 2. Notice that if you were to go back and to distribute that, you would end up with the original problem. That's how you know that what you've done is correct. Okay, so now the only thing we have left to do is to name the solutions or the roots or zeros. So here we're going to name those. And what's written in parentheses is really easy. That's just the opposite. So that's +2, 0. Sometimes people get confused on this and what's the outside. Sometimes people say -4 because there's a +4 there. But think, -4 would have been written x plus 4, right? I don't have parentheses here. So if anything is written by itself on the outside or as a GCF, the answer there is just 0. So you'll want to make sure that you have that noted in your notes for class. Factors on the outside of parentheses give roots at 0. All right, so here's another example. Again, we said we want to take the GCF out first, so I'm going to identify if there's a GCF. If I look here between all 3 of these terms, I can divide a 2 out. So remember, GCF means I'm going to divide, so I'm going to rewrite my problem, x squared minus 5x plus 6. And now we're back to, I don't know if you've seen this method before or not, but this is kind of how I set it up. I know I need 2 numbers, right? I'm trying to pick 2 numbers that are going to multiply to give me 6, and they're going to add to give me -5. I always set mine up looking like a puzzle like this, but however you want to write that out for yourself. So 2 numbers that multiply to give me +6 and add to give me -5. Be really careful about your signs here, so pause and think if you can come up with those two numbers. And you should be getting -2 and -3. Okay, so we're going to use those to write our factors. That's going to make our factors become x minus 2 and x minus 3. Exactly the same numbers that you picked to fill out your puzzle. Now, we do want to bring the GCF down to keep the factored form correct. Y equals 2, x minus 2, x minus 3. And then for each x in the equation, we're going to name our solutions. So our solutions here are going to be, there's no x out here with the 2, so it does not contain a solution. Right here, I've got a solution of +2, 0, since we're supposed to think opposite. And here I have a solution of 3, 0. That means that whatever this parabola looks like, I know that it's going to cross the x-axis at 2 and at 3. And I also know, I could figure out a few other things about it, right? I know the y-intercept is going to be here at 12. But that's really the biggest thing we're figuring out, is that it crosses at 2 and at 3. Now, this problem, if you look at it, you know our first step is supposed to be to take out the GCF. But if you look at this problem for a minute, you might notice there's not a GCF. There's not a number I can divide by all three of those other than 1, which you can divide that, but you know it's not going to change anything. So the problem now is that I have this number out here in the front, this number that's a 5, and that changes some things. Really what we're doing is called AC method, if you've heard it that way, but this number needs to move to the end for a minute. So I like to call this bottoms up method, and you'll see why in a minute. So I call this bottoms up. If I set up my problem now, if I move that to the end, that's going to give me -15 is the number that I'm multiplying by, because I've taken this 5 and I've multiplied it to the end. And I need two numbers that are going to add to give me -2. So if I think about those numbers for a minute, it's just a coincidence. Those two numbers are going to be -5 and +3. All right, so I'm going to go back and write my factors like I just said a minute ago. I'm going to use those two numbers, x minus 5 and x plus 3. Now, we multiplied here at the end, right? We moved that for a minute, but I can't just multiply to the end just because I want to. I've got to do something to fix that. So I need to undo that multiplication. And how do we undo multiplication? We divide. So I'm going to divide both of my numbers by 5. All right. This kind of gets tricky, but once you see this method and we work with it for a little while, you're going to feel a lot better. Okay, so if we divide here, -5 divided by 5, if it divides, you can just simplify the factor in that way. So this just becomes x minus 1 because that divides well. Well, 3 does not divide by 5, and it doesn't even simplify 3/5, right? That just stays 3/5. So instead, I'm going to do what I call bottoms up. I like to think about this like a circle, right? I've moved this number to the end, so I have to undo that and bring it back. So I'm going to bring that number full circle, and I'm going to bring it up bottoms, right? It's on the bottom. I'm going to bring it up to the front. That's going to make this factor now 5x plus 3. So if I write my factored form, that gives me y equals x minus 1 times 5x plus 3. And then we want to go back and we want to name our solutions or our roots or x-intercepts. I'm going to use those words over and over. And I have solutions of +1, 0. And this one gets a little bit tricky because I've got that 5 in the front. So I can't just name this as -3. So I'm actually going to look back up to this original problem and see what that would have been. So I notice in that original problem that looked like x plus 3/5, which means my root is actually going to be -3/5, 0. We'll practice these if we need to in class. You can put a little star next to whichever examples you feel like you want to spend the most time on. All right, this example, so we're going to do GCF. Again, here I can't take anything other than a 1 out, so that's going to leave my problem exactly the way it was. And this problem is even easier. There is no number in the front, right? That's just a 1, so that's not going to change anything. So I can go ahead and set up my problem, or my puzzle rather. I need two numbers that multiply to give me 8 and add to give me 6. And if I think about that for a minute, that gives me 4 and 2. So my factors are going to be x plus 4 and x plus 2. The only GCF is 1, which I don't even really need to write. So that's going to give me a factored form, y equals x plus 4 and x plus 2. And then I'm going to go ahead and name my roots, and those are -4, 0, and -2, 0. All right, some of these are actually just that simple. All right, there's one more type of problem. So in this problem, again, we want to start in the same place. My GCF is going to be 2, so I'm going to simplify my problem, divide that out. That gives me x squared minus 25. Now notice here, there's kind of a problem. You're missing a part, right? I don't have like ax squared plus bx plus c. I don't have that middle part. So because I'm missing the middle, there's kind of a shortcut you can make a note of here. And that is to say that if the middle is missing, we're going to try what's called difference of squares or conjugates, depending on how you've been taught that in the past. So the idea here is I need to pick two numbers that, if I keep that same puzzle idea, I need to pick two numbers that are going to multiply to give me -25 and add to give me 0 because the middle is missing. And if you think about that, the only numbers that you're going to be able to come up with are -5 and +5. So that's going to make my factors x minus 5 and x plus 5. All right, this is called difference of squares. Difference first because this is subtraction, so it only works with subtraction. Squares, because 25 and x squared are both perfect square numbers. And then conjugates, we talk about that because these two answers look exactly the same except for that positive or negative sign in the middle, right? One is always positive and one is always negative. So if we continue this like we have our other problems, we're going to bring the GCF of 2 down. So I'm going to have y equals 2, x minus 5, x plus 5. And then we're going to go ahead and name our solutions. And those are going to be +5, 0 and -5, 0. And again, these solutions are just going to be the spots, the x-intercepts, where our parabola is going to cross the x-axis. So make sure you have these examples. We are going to spend as much time as we can in class tomorrow really digging into these examples for your test.